All right, welcome to The Explainer. Today, we're talking about something that feels like it's straight out of science fiction, but it is very, very real. It's a technology that's literally breaking our computers out of their screens and into the world around us. We're talking about spatial computing. I mean, just think about it for a second. Our entire lives, computers have been these glowing rectangles, right? Phones, TVs, monitors. But what if they weren't? What if your computer could just break free? Imagine a world where the digital stuff you use every day could just seamlessly blend with your physical space. That is the huge idea we're going to unpack today. Okay, so here's how we're going to break it all down. First, we'll get past the buzzwords and figure out what spatial computing actually is. Then we'll peek under the hood to see how it works. After that, we'll check out the hardware you can get right now, see how it's being used in the real world, and wrap up by looking at what's coming next for our reality. All right, first up, what on earth does spatial computing actually mean? And, why are some of the biggest companies in the world betting their entire future on this idea? Well, to put it simply, it's about computers that can actually understand the physical space you're in. I mean, your walls, your desk, the floor, all of it. So instead of you just staring at a flat screen, the computer can place digital information right into your world. And you can interact with it just by, say, looking at it or pointing or using your voice. The digital and physical worlds, they stop being two separate things. They literally start to blend together. To really get this, it helps to start with two terms you've probably already heard a million times: AR and VR. So, augmented reality, or AR, that's when you're overlaying digital stuff onto the real world. But with virtual reality, or VR, you're completely blocking the real world out. But to truly understand spatial computing, there's a third really crucial category we need to talk about. And that, my friends, brings us to MR. Mixed reality. This is really the sweet spot. It's where devices like the Apple Vision Pro and the Meta Quest 3 live. They use cameras to show you your actual room, but then they mix in virtual objects that can actually interact with your space. So imagine a 3D model of the solar system floating right above your coffee table, and it's even casting a shadow on your rug. That right there, that's the magic of MR, and it's a huge, huge piece of the spatial computing puzzle. So how in the world is any of this even possible? Let's pull back the curtain for a second and look at the core tech that makes a digital object feel like it's really physically right there in the room with you. Okay, it all starts with this amazing technology called SLAM. That stands for Simultaneous Localization and Mapping. Now, the best way to wrap your head around this is to imagine the device is building an invisible Minecraft version of your room, but it's doing it in real time. It's constantly figuring out where it is, building a 3D map of your walls and furniture, and then it can anchor digital objects to that map. That's exactly how a virtual lamp can sit on your real-life desk and just stay there. But just mapping the room is only half the battle, right? To make it all look convincing, you need some seriously clever tricks. First, pass-through cameras give you that live video feed of your surroundings. Then there's something called occlusion, which is what lets a virtual object realistically hide behind your real couch. But the real stroke of genius here is foveated rendering. The device actually tracks your eyes and only renders the tiny spot you're looking at in super high definition. Everything else in your peripheral vision, it's lower res. This saves a ton of processing power, which means longer battery life for you. And of course, how you control all this stuff is changing completely. We're moving way beyond clunky keyboards and mice. The new goal is totally natural inputs. So with Apple's Vision Pro, you literally just look at a button and pinch your fingers together to click it. On a Meta Quest, you can just reach out and touch a virtual screen with your own hands. It's this incredibly intuitive shift that just makes you feel way more connected to what you're doing. Now, this part might sound a little technical, but it is so important. None of this can really take off without common standards. You've got OpenXR, which basically lets a developer build an app just once and have it run on a whole bunch of different headsets. And then there's OpenUSD, which was actually pioneered by Pixar, and it's like a universal translator for 3D stuff. So artists can move complex scenes between different programs without everything breaking. Seriously, these two are the unsung heroes that keep this whole world from becoming a fragmented, chaotic mess. Okay, so this all sounds really cool, but what can you actually go out and use right now? I know, the hardware market can seem super confusing, but if we break it down with an analogy, it's actually pretty easy to get a handle on the main players.
Yeah, just think of it like a car dealership. You've got the Apple Vision Pro, that's your luxury sedan. It's premium, it's powerful, and it's really built for professionals and creators. Then you have the Meta Quest 3. That's your affordable, do everything SUV. It's perfect for the mainstream, great for gaming, super versatile. Then there's stuff like the HoloLens 2. Think of that as an industrial truck, built for really specific enterprise jobs. And finally, you have smart glasses. They're like the lightweight city bike, great for quick, everyday things like taking a call or snapping a photo on the go.
Okay, so enough about the tech specs and the hardware. Where is spatial computing actually making a difference in the real world? Because this isn't some sci-fi dream for the distant future. It's already here, and it's solving real problems in some pretty surprising places. Let's start with healthcare. I mean, check this out. Surgeons are now training for incredibly complex procedures in VR. It's a totally risk-free environment to practice in. Some of these platforms even use haptics so a trainee can actually feel the resistance of tissue on a virtual scalpel. It's wild. And the results? They really speak for themselves. The data shows that surgeons who train this way are faster, they're more confident, and they're just flat out better at what they do. And you know what? Chances are you've already used a simple form of this on your phone without even realizing it. Have you ever used the IKEA app to see if that 3D sofa will actually fit in your living room? Or maybe the Warby Parker app to virtually try on glasses? Yep, that's spatial computing. It's a simple idea, but it's an incredibly powerful tool for retail that makes you more confident in what you're buying. And it massively cuts down on returns. It's also completely changing the way we work and design things. Instead of just another boring, flat video call, Microsoft Teams now lets you join meetings as a 3D avatar in a shared virtual space. Or think about a field technician who can get real-time help from an expert who is literally drawing instructions right onto their view of the world. And in the design world, creatives are using tools like Gravity Sketch to sculpt a full-size car together in VR before they even touch a single piece of real clay. It's a game changer. So that brings us to the big question. Where is all of this headed? The technology is moving at an incredible speed, and that forces us to stop and ask some really big questions about the kind of future we're all building together. And honestly, this might be the single most important question of all. I mean, if these devices are mapping the inside of our homes and tracking what we look at, they're collecting a mind-boggling amount of incredibly personal data. So the critical question we have to ask is, who can we trust with all of that? Well, the good news is the industry knows that privacy is an absolute deal breaker. The best approach, and what we're seeing more of, is to process the most sensitive data right there on the device itself. A great example is Apple's Optic ID. That iris scan data never leaves the headset. You also have independent groups creating privacy standards, and even simple design choices, like putting a visible recording light on smart glasses, are absolutely crucial for building that social trust. Okay, so beyond privacy, there are three major trends happening right now that are basically screaming that a huge wave of innovation is just around the corner. First, the main operating systems, like Vision OS and Horizon OS, are evolving at a breakneck pace, constantly adding new features. Second, the whole ecosystem is opening up. Meta is now licensing its software, which means we're about to see a lot more hardware options from brands like Asus and Lenovo. And third, those super important standards we talked about, OpenXR and OpenUSD, are finally getting solid. That's going to make it so much easier for developers to unleash a whole new generation of creative apps. And this really gets to the heart of the matter. The technology itself is just astounding. But at the end of the day, it's absolutely nothing without our trust. Protecting our privacy and making sure this stuff is safe is every single bit as important as building the next cool piece of hardware. So we end right back where we started with a big question. This technology gives us the power to literally reshape our reality. And that isn't just a technical challenge. It's a deeply human one. As these two worlds, the digital and the physical, continue to merge, the real question is, what kind of reality will we choose to build? That's the question this technology leaves with every single one of us.